In the first scenario, we determine the direction of the magnetic field for a charge moving into the page using the right-hand palm rule. Our four fingers represent the charge's velocity which facing away from us. If the point of interest is above the charge, our palm faces up, and our thumb, representing the magnetic field, points right. Similarly, if the point is on the left, our palm faces left, and our thumb points up. If the point is below, our palm faces down, and our thumb points left. Connecting these arrows forms a full circle, as shown in the diagram.
So for the second scenario, we will determine the direction of the magnetic field of charge moving out of the page. This time, our four fingers will face towards us. Let's say the position of interest is above the moving charge, then our palm will face upwards, and our thumb that represents the magnetic field will point to the left. If the position of interest is on the right side, then our palm will face to the right and our thumb will face upwards. Again, if we connect the arrows of these points, we will get a full circle like the diagram shown. For the quantitative relationship of magnitude of the magnetic field produced by a moving charge follows a similar concept to what we learned in Chapter 1. However, in Chapter 1, a stationary charge produces an electric field, while a moving charge produces a magnetic field. Just like before, a greater charge results in a stronger magnetic field. The magnetic field is stronger when the position of interest is closer to the moving charge. Additionally, the faster the charge moves, the stronger its magnetic field. Lastly, if the position of interest is at an angle in front or behind the moving charge, the magnetic field there will be weaker compared to when it is perpendicular to the charge. This is because the magnetic field is directly proportional to the sine of the angle between V and R, and we know sine 90 is the maximum. We determine the direction of magnetic field of straight CCC using the right-hand grip rule, where this time the thumb represents the direction of velocity of charge, while the curled fingers represents the direction of magnetic field. Our fingernails act as the arrowhead. The direction of magnetic field of straight current-carrying conductor is actually the same as magnetic field of moving charge because current is just many moving charges.